Hey everyone, and welcome. Today, we're going to tackle one of the biggest, most fundamental challenges in all of artificial intelligence. It's absolutely terrible memory. We're going to explore a pretty groundbreaking new idea that might just be the cure for AI's, let's call it, chronic case of amnesia. So let's dive in.
So what is it? What's the single greatest weakness holding AI back from learning the way you and I do? It's not about more power. It's not about more data. It's something much, much deeper. A problem that we're going to unravel right now. I mean, just look at this contrast. On one side, you have the human brain. It's the gold standard for a reason, right? It's constantly adapting, growing. That's neuroplasticity. We can learn new things without just deleting the old ones. But then you have current AI. Its knowledge is static. When you try to update it, it has this horrible tendency to forget what it already knew. It's completely stuck inside its little context window.
And that brings us right to the heart of the issue, a problem that has been a thorn in the side of researchers for years, AI's big memory problem.
The fancy technical term for this AI amnesia is catastrophic forgetting. Seriously, imagine you have a model that's an expert on, say, 19th century literature. Now you decide to teach it about quantum physics. The very real risk is that in learning physics, it might just, poof, completely erase everything it knew about literature. That's catastrophic forgetting in a nutshell.
So why on earth does this happen? Well, for decades, the real cause has been hiding in plain sight, baked right into how we design these systems. Think of it like a puzzle that we've been trying to solve with two pieces that were never really meant to be separate. See, this is the old way of doing things. Step one, an engineer designs the model's architecture, its skeleton, its layers, the whole structure. Then, step two, they grab a completely separate optimizer, which is basically the rule book that tells the model how to learn. The structure and the learning rules have always been treated as two totally different things.
And this right here is the crucial point. This fundamental separation, this disconnected approach, it's the villain of our story. It's the very thing that stops AI from having a truly unified and efficient learning system like the one in our own heads.
But what if that separation was just wrong? This brings us to a really revolutionary new idea, a unified theory of learning that might just solve this memory problem once and for all. It's called nested learning, and the core idea is actually brilliant. It says, hey, let's stop treating the model's design and its training like two different jobs. Instead, let's see the model for what it is, a whole system of smaller learning problems, all nested inside each other, all being solved at the same time.
This all boils down to a really powerful insight from the researchers behind this. The model's structure and the rules for training it, they aren't separate. They are fundamentally the same thing, just operating at different levels, or you could say at different speeds, inside the same system.
Okay, so how does this actually work? Well, in this new way of thinking, different parts of the model learn at different speeds. Some parts update super fast, kind of like short-term memory. Other parts update very slowly, like our deep, long-term knowledge, just like a brain. This opens up a whole new dimension for designing AI, not just space, but time and frequency.
Now, theory is one thing, but does it actually work in the real world? To prove it, the researchers built a brand new architecture from the ground up based on these principles. Everyone, meet Hope. Hope is the proof of concept, and it's pretty wild. It's a self-modifying model. That means it can literally optimize its own memory while it's learning. Its secret weapon is something called a continuum memory system. Don't think of it as just short-term versus long-term. Think of it more like a whole spectrum of memory, from fleeting thoughts to core knowledge, all updating at different speeds. It's designed for basically infinite levels of learning.
This all sounds incredible, right? But here's the real test. How does this new kid on the block actually perform against some of the best, most established models we have today?
Well, the results are seriously impressive. When it comes to things like common sense reasoning, Hope is consistently at the top of the pack. It gets a higher accuracy score than heavyweights like the Transformer and Titans. And look at perplexity. That's basically a measure of how confused a model gets by new stuff. Lower is way better, and Hope gets the lowest score of them all. But here is where Hope really shines. Memory. In these needle in haystack tests, which are designed to see if a model can find one tiny detail in a massive wall of text, Hope achieves a staggering 98% accuracy. That's a massive deal. It's clear proof that this continuum memory system is the real deal. So let's zoom out. What does this all mean for the future?
This isn't just another small improvement. This is a fundamental shift in how we might build AI that can actually learn and get better all on its own. The researchers themselves put it perfectly. They said this is a major step toward closing that gap we talked about at the very beginning, the huge gap between the forgetful AIs we have now and the incredible continuous learning machine that is the human brain. Ultimately, what this gives us is a whole new dimension to play with when we're designing AI. By nesting these learning processes, by letting them run at different speeds, we can build AI with much deeper computational abilities. We can create systems that aren't just more powerful, but are just fundamentally better and more efficient at learning. And this leaves us with one last fascinating question. With breakthroughs like nested learning, are we finally on the right path to creating an AI that can learn and grow and adapt for its entire existence without ever forgetting? The answer to that could change absolutely everything.